Hi, this is your PC software, and then you just click File, New, and occurs one new empty workspace. Okay, so we need to draw the figure 1.3 here. Okay, this figure. So, okay, I make it small. So, we need to draw this figure, which is, this figure have 1 DC and 1, 2, 3, 4, 5 resistor. Okay, let's go. First, voltage supply VC. So, VC is here, DC voltage source. Can you see that? Okay, here. Here. DC voltage source. So, I choose this one. I click this one and paste. So, this is you paste it in vertical. So, if you want to rotate this DC, you just right click your mouse like this. Now, I right click. So, it will rotate. Okay? Okay, if I don't want it anymore, I choose, this is the select button. Okay, next, I want to paste a resistor. So here, choose resistor here. Okay, so just paste it. 1, 2, 3, 4, and the 5 one is vertical, so I right click 5. Okay, so I don't want, select button. Okay, when you in a select button mode, you can move around your element to make it organized. Okay, now we need to set all the value. So first, DC is set to 5. So just double click and 5. Okay. This one, for example, this one 1K, so 1,000. So I want to show the value and the tag. So just click. If you don't want to show it, you don't untick that. So 1,000. This one is R2. I tick this one to display. R3. R3 is 1.5K. And then R4. R4 is 3K. Okay. Show. Better to show it all. This one R5. R5 is 1.5K. Okay, I display this one. And then, before you connect all the wire connection, the lab procedure asks you to measure all the current I1, I2, I3, I4, and I5 at each branch. So, tools to measure the current is by using the ammeter here, current probe. Here at the bottom here, this is a current probe. So I choose this one and I put it at the branch of I1, I2, I3, I4, and I right click to make it vertical, and I5. Why I put it at the side of resistor? Because when you want to measure a current, you need to connect it in series, not a parallel. Okay? So I think, okay, two ups, so I move it a little bit slightly down, and you choose the wire button to make all the connection connected. So this one to this one to here, and So here, oh, this one I did not show it right, so it's okay. Here is okay, so I double click, display lah, to display the value. So better to display the value to make it nice. Okay, so I continue here, I continue here, continue here, continue here. So don't forget to put the ground. Okay, so I already done to draw the circle. Simple and easy. So I would like to simulate this one to get the value of, this is I1, I2, I3, I4 and I5. So what you must to do is you just click the simulate and run the simulation. So when you want to run the simulation, so for sim view properties, you must select which variable you want to add for display. So of course we need to display all this current. So I choose all and okay. So this is the graph for the sim view. So in this sim view, okay, I make it small for you to see it. When you want to get the value, measure, takes the measure. Okay, we take the measure and then kenapa ni? Okay, sorry, I think I click it wrongly. Okay, this is the right. Click the measure. Okay, measure here, and then the measure window will occur, and it will show you the value of I1, I2, I3, I4 and I5. So this is the value. So how to read this? Okay, how to read this one? This one is 1.67 times 10 to the power of negative 3. Okay, I2 is 8.33 times 10 to the power of negative 4. So I3 is 5.55 times 10 to the power of negative 4. I4 is 2.78 times 10 to the power of negative 4. And I5 is 1.67 times 10 to the power of negative 3. Okay, negative 3 means milliampere. Okay, so all these results, you must key in it inside the result sheet. Okay, which one is the result sheet? Here at your lab manual. So this is your table 1.1. Okay, in this table 1.1, before you perform this lab, you need to do the calculation by using your knowledge. What you have learned in circuit 1 theory, you calculate first and then you compare with the measurement value. Okay, that value, you may pause the video and you may write the measurement value for 5 volt. Okay, now I would like to run for VDC 10 volt. Okay, let's go. So I put it down, double click the VDC and change it to 10 volt. Okay, after that, just simulate, run the simulation. Okay, wait. Okay, I close first this one. Okay, simulate, run the simulation, and I perform the same procedure. Okay, so measure. Okay, this one is the results for V equal to 10. Okay. For I1, 3.33 times 10 negative 3. I2, 1.67 times 10 to negative 3. I3, 1.11 times 10 to negative 3. I4, 5.56 times 10 to negative 4. I5 is 3.33 times 10 to negative 3. Okay. If you see the circuit, okay, I would like to show you I1 and I5. Actually, I1 and I5 is the same value. Why? You can see the circuit here. Okay, I will show you. I show you the circuit. So, I1 and I5 actually is the same branch. Okay. So, the difference is only in I2, I3 and I5. So, if you get the results, the same value, so your result is no problem. Okay, now I would like to do for the V equal to 15. Okay, I go to the result sheet. Here, V equal to 15 volt. Okay, so just change here. 15. Okay, and then I run the simulation. The same procedure, add all the current probes. Okay, and then measure. I put, okay, here. This is for the 15 volt. So I want 5 milli, 2.5 milli I2, I3 1.67 milli, I4 0.833, I5 4.9 milli. Okay. So I think you already have all the result for table 1.1. Next, let's go to perform Kirchhoff voltage law.